Hi everyone, welcome to the YouTube channel of ChemLover. So today we are going to discuss lecture 03 of organometallic chemistry. In this lecture, we will discuss HNCC, high nuclearity carbonyl compounds. Basically, we will learn how to determine skeletal electron pairs using Wade's rule and how to determine structure. Now let's start the topic, that is organometallic chemistry, skeletal electron pair determination. Basically, in this lecture, we have to use Wade rule. We have to use Wade's rule for high nuclearity carbonyl compounds. So what are high nuclearity carbonyl compounds in which the number of metal atoms is greater than 4? Number of metal atoms is greater than 4. All those cluster compounds in which the number of metal atoms is greater than 4, they are known as high nuclearity carbonyl compounds. So basically in high nuclearity carbonyl compounds, we use Wade's rule to determine structure. So basically the first step involves, step first will be determination of TEC. Step first will be TEC, calculation of TEC. What is TEC? It is total electron count. Total electron count. First we have to determine total electron count of a cluster. Total electron count of a given organometallic cluster, isn't it? So this is the step first. In the second step, we have to determine skeletal electron pairs. Skeletal electron pairs. Skeletal electron pairs. We denote this skeletal electron pairs by S. So this S will be equal to TEC, total electron count, minus 12 into N. So in this case, we use 12 into N. In this case, we use 12 into N. But in case of low nuclearity carbonyl compounds, where the number of metal atoms is less than 4, we use 18 into N divided by 2. So this is the formula, this is the Wade rule by which we can, this is actually the Wade rule. So in Wade rule, we have to first determine TEC, total electron count of a cluster. And then we have to use this formula to determine skeletal electron pairs, that is total electron count minus 12 into N. What is N? N will be the number of metal atoms present in the cluster divided by 2. So if N comes out to be 1, if N comes out to be 1, or we can say that if we have a number of skeletal electron pairs, if number of skeletal electron pairs, so basically S skeletal electron pairs, skeletal electron pair, if it comes out to be N minus 1, if it comes out to be N minus 1, if S comes out to be N minus 1, then the structure is known as supercloso structure. Then the structure is known as supercloso structure. A lot number of questions have been asked from this. If this skeletal electron pair comes out to be N, then the structure is known as hypercloso. Then the structure is known as hypercloso. So this is very important. If the number of skeletal electron pair it comes out to be N plus 1, then it is called closo. Then the structure is called closo. And if it comes out to be N plus 2, then it is called nido. And if it comes out to be N plus 3, then it is called arachno. And if it comes out to be N plus 4, then it's called a clad. So we have different types of structures which can be had from this skeletal electron pair determination. If this skeletal electron pairs, if it comes out to be N plus 1, N minus 1, then the structure is called supercloso. If it comes out to be N, then it's called hypercloso. If N plus 1, then closo structure. If N plus 2, then we will get nido structure. If N plus 3, then arachno structure, and N plus 4, then we will get colloidal structure. Basically, these rules are analogs of boron compounds, where we also use Wade's rule for boranes. So now, moving forward, we can also determine number of vertices. Question have also been asked on this, number of vertices in a cluster. So this number of vertices, it is equal to skeletal electron pairs minus 1. So first we have to determine skeletal electron pairs, then we have to subtract 1, we can determine number of vertices. We'll explain this thing by taking examples, isn't it? So in these clusters, sometimes there may be encapsulated atoms. So in these clusters, sometimes there may be encapsulated atoms. Encapsulated atoms. So we have to count electrons from these encapsulated atoms as well. For example, carbon may be encapsulated, hydrogen may be encapsulated in the metal cluster, nitrogen may be encapsulated, phosphorus may be encapsulated, arsenic may be encapsulated, or sulfur may be encapsulated. These are called encapsulated atoms. So we'll see with the help of examples how we can take these encapsulated, how we can count the electrons for these encapsulated atoms, isn't it? Now let us move to the structural determination of certain compounds. So we have certain examples over here and we will determine structure of these compounds. So this is example number first. We have ruthenium complex RH6CO16. We have to determine whether this is nido, closo, or arachno, or super closo, or whatever may be its structure. So basically first we will determine TEC. TEC is total electron count. So basically in this complex we will determine TEC. So TEC, how we can determine TEC? There are 6 ruthenium atoms. So valence electrons on this ruthenium, it is 9. So 6 into 9 plus valence electrons from carbonyl ligand. Carbonyl ligand denotes 2 electrons, but we have 16 such ligands. So this will come out to be 6 9s are 54 plus 2 16s are 32. So your total electron count, it comes out to be 86. So this is total electron count. Then we have to apply Weights rule. We have to determine skeletal electron pairs, that's S. So skeletal electron pairs is equal to TEC minus 12 into N divided by 2. So TEC basically is 86 minus 12 into N. N is the number of metal atoms, which is 6 in the present case, divided by 2. So basically you will get 86 minus 72 divided by 2. So you will get 86 minus 72, that is equal to 14 by 2. 14 by 2 is equal to 7. So skeletal electron pairs in this complex is 7. So in the examination, you are asked a question, how many skeletal electrons are present for a particular cluster? So in this case, skeletal electrons are, the number of skeletal electron pairs is equal to 7, isn't it? Now, since we have n number of atoms, so ruthenium atoms in this case is equal to n, isn't it? Ruthenium atoms is equal to n. So n over here is 6. So we can say 6 plus 1 is equal to this 7. So basically this 6 is n. So the structure is n plus 1. So S is equal to n plus 1. Skeletal electrons is equal to n plus 1. When the number of skeletal electrons comes out to be n plus 1, so the structure is closo structure. So this complex has closo structure because the number of skeletal electrons comes out to be n plus 1. Next thing we will determine for this structure, we'll determine one more thing, that is number of vertices. So basically I have told you number of vertices is equal to, if we talk about vertices, number of vertices is equal to S minus 1. So basically S in this case is 7. So 7 minus 1 is 6 vertices. So this complex contains 6 vertices. Whenever there are 6 vertices, these 6 vertices are occupied these metal atoms to give it octahedral structure. Octahedral structure. So what is the structure? It is closo octahedron. So the structure of this complex is closo octahedron, isn't it? Now let us take this type of complex. So in this case, first we will determine TEC. So TEC will be equal to number of metal atoms is 5 and the valence electrons of osmium is 8 plus number of carbonyls is 15 and the electron is donated by carbonyl is 2. So this comes out to be 40 plus 30, 15 to the 30, that is 70. So this comes out to be 70, isn't it? So let me check again. 5 8s are 40 plus, plus we over here we have carbon. This carbon is encapsulated atom. So we know that carbon has 4 valence electrons, plus we have to add these 4 electrons, that is electrons from encapsulated atom. So this will come out to be 74. Then we have to determine skeletal electron pairs, that is equal to TEC minus 12 into n divided by 2. So basically TEC is 74 minus 12 into n. N is the number of metal atoms, that's 5 divided by 2. So this will come out to be 74 minus 60, that is 14 divided by 2. 14 divided by 2 is equal to 7. So basically S comes out to be 7. So in this case S comes out to be 7. Skeletal electron pairs come out to be 7. But you can see in this case the number of metal atoms, that is equal to 5. So over here number of metal atoms, that is equal to 5, n is equal to 5. So what we have to add to this 5, we get skeletal electron pairs, that is the structure is n plus 2. N plus 2 is equal to 7. So since the structure is n plus 2, therefore this compound has nido structure. It's a nido cluster, isn't it? I hope this thing is clear to you. It's a nido cluster. Then we have to determine vertices. Vertices is equal to S minus 1. So S over here is 7. 7 minus 1 is equal to 6. When there are 6 vertices, then it is octahedron. So the structure is nido octahedral. nido-octahedron structure. I hope things are very much clear to you people. Now let us take one more example. So in this example, first we will determine TEC. By taking more and more examples, this concept gets clear. So TEC is equal to 5 into valence electrons of osmium, that's 8, plus 16 into 2, that is 32. So this comes out to be 72. Then we have to determine skeletal electron pairs, that is TEC 72 minus 14 into n. So 14 into n is basically 12 into n. So 12 into n is 12 into 5. 12 into 5 is equal to 60 divided by 2. So this comes out to be 12 by 2. 12 by 2 is equal to 6. So skeletal electron pairs come out to be 6. Isn't it? But n in this case is 5. So n plus 1 is equal to 6. Because n is equal to 5. 5 plus 1 is equal to 6. So basically we have n plus 1 structure. Whenever we have n plus 1 structure, according to Wade rule, it should have closure structure. Isn't it? Now let us see number of vertices. So vertices in this case is equal to f minus 1. S minus 1 is equal to 6 minus 1. 6 minus 1 is equal to 5. So when we have 5 vertices, so when we have 5 vertices, structure is TBP, trigonal bipyramidal. So it is closure TBP, trigonal bipyramidal geometry, but closure because only 5 vertices are occupied. So over here we can have metal atom like this, it will occupy vertex, metal atom like this, metal atom like this, metal atom like this, they will occupy vertices. So we have 5 vertices in this case, and there will be then the carbonyl ligands, isn't it? Then there will be carbonyl ligands attached to these metal atoms. So let us take this type of example. So in this case, TEC is equal to basically 4 metal atoms are there, and valence electrons of iron is 8. Plus electron is donated by this encapsulated atom, that's carbon, it has 4. Plus electron is donated by this carbonyl, 12 into 2 is equal to 24. Since or here the charge is minus, means we have to add these electrons. Minus charge means gain of electrons plus 2. So this will come out to be 8 4s are 32, 32 plus 8 4s are 32 plus 4 36, 36 plus 24 60. This will come out to be 62. So now determine skeletal electron pairs, that is 62 minus 12 into n. N over here is 4, 12 into 4 divided by 2. So 12 4s are 48. 62 minus 48 divided by 2. So this will come out to be 14 divided by 2, and this will come out to be 7. So in this case, skeletal electron pairs come out to be 7. Now let us check the structure. N in this case is 4, or here you can see n is equal to 4. So we can say 4 plus, or we can say n plus 3 is equal to n plus 3 is equal to skeletal electron pairs. Is it n plus 3 is equal to 7? So n basically is 4. So 4 plus 3 is equal to 7. So over here the structure contains n plus 3, isn't it? So over here we have n plus 3. Clear? Is it clear? So whenever we have n plus 3 structure, then the structure is arachno. So it's a arachno cluster. Arachno. So the compound has arachno structure. This compound has arachno structure. Now let us determine number of vertices. So vertices will be equal to s minus 1. So s basically in this case is 7. So that is 7 minus 1, that is 6. So since we have 6 vertices, it is octahedral geometry. So we have arachno octahedral geometry. I hope the things are clear to you. Now let's take few more examples. So we have this type of complex. In this complex, we have hydrogen atom as encapsulated atom. Hydrogen has 1 valence electron, therefore 1 will come from here. Because we have 3 hydrogen atoms, that means 3 into 1. Then we have ruthenium atom. So ruthenium atom belongs to the iron group. So it has 8 valence electrons. So TEC will be equal to 3 from hydrogen atoms, that's 3 into 1, plus A 4 into 8, plus 12 into 2. This charge is minus, therefore plus 1. Divide. So this will be equal to 3 1 is 3, 3 plus 1 is equal to 4, 8 4 are 32, that's 36, 36 into 24 is equal to 60. Then we'll determine skeletal electron pairs. So skeletal electron pairs is equal to 60 minus 12 into n. 12 into n, n is 4, 12 into 4 is equal to 48 divided by 2. So this will come out to be 60 minus 48, that's 12 by 2. 12 by 2 comes out to be 6. So the skeletal electron pairs come out to be 6. In this case, n is equal to 4, means n plus 2 is equal to 6. 4 plus 2 is equal to 6. That means 4 plus 2 is equal to 6. 6 is equal to 6. So the structure will be nido structure. Whenever we have n plus 2, structure will be nido structure. Now let us see skeletal, let us see vertices. So vertices is equal to skeletal electron pairs minus 1. That is 6 minus 1. 6 minus 1 is equal to 5. So whenever we have 5 vertices, structure is TBP. So in this complex, the structure will be nido TBP. I hope the things are clear now. Now let us take one more example. Then further you can solve examples on your own. Now again we have ruthenium, so we'll determine TEC. So TEC will be equal to 5 into 8 because ruthenium has 8 valence electrons plus nitrogen. Over here we have nitrogen. Nitrogen has 5 valence electrons, that means plus 5 plus 14 into 2. 14 into 2 is equal to 28 plus 1. 1 is from this negative charge. So 8 5s are 40. 40 plus 5 plus 1, 6 is equal to 46. 46 plus 28. So this is 46 plus 28. So this will come out to be 74. This will come out to be 74. Then we have determined skeletal electron pairs. That is 74 minus 12 into n, 12 into 5 divided by 2. So this will come out to be 74 minus 60 divided by 2. So this will come out to be 14 divided by 2. So 14 divided by 2 is basically 7. So S comes out to be 7. But in this case, n is equal to 5. So n is equal to 5. So we can say n plus 2 is equal to 7 because we have to equal this to 7, n plus 2. That is 5 plus 2 is equal to 7. So the structure is n plus 2 based on Wade's rule. Therefore, it has nido structure. It has nido structure. Again, you can see vertices in this case is equal to S minus 1. S minus 1 is 7 minus 1. Therefore, you have 6 vertices. Whenever you have 6 vertices, it is nido octahedral. The structure is nido octahedral. Thanks for being watching this lecture. In the next lecture, we will explain I am going to explain you zintal ions, structure of zintal ions. So in the next lecture, we'll discuss zintal ions. If you really like my videos, please do share and subscribe with your loved ones. Thank you.